These two simultaneous equations can be solved a third way. So we've got graphical method, elimination, and then really the most general method that works in every situation is the substitution method. The trouble with the elimination method is that it tends to only work if the equations are linear. In other words, there's no powers of x. What would I do if I got x squared or x cubed or sine x, something like that, some other function involving x? It would be very difficult to get them to be the same, possibly, in the equations. So in that case, we'd have to use the method of substitution. As far as the assignment's concerned, for Unit 4, you can use the elimination method because they're two linear equations that you'll be has to solve. But I want to just show you this idea. It requires a little more confidence with algebra, this method, because what you do is you take one of the equations, 1 or 2, and rearrange it so that it says x equals something or y equals something, and then you substitute that term into the second equation instead of the other variable. Let me show you what I mean. So what I'm going to do is to rearrange equation 1 for y. Well, no, for x. It's probably a bit easier to do it for x. So I'm going to take equation number 1 and get x on its own. 5x minus 4y equals 12. This is like a formula now. I'm after getting x on its own. What's the first thing to do? Plus 4y to both sides. 5x equals 12 plus 4y. Now what do I do to get x? Divide by 5. X equals, the right hand side, to show it divided by 5, the easiest thing to do is just take the whole thing and divide it by 5. So all divided by 5. So now I've got an expression. This expression on the right hand side here is the same as x. So what I can do is I can go to the second equation, number 2, and wherever it says x, I can write that expression. And the beauty of it is that that expression only involves y, so I'll only have one unknown. So what I do is I substitute into 2. And what that means is I rewrite equation number 2, 3x plus 2y equals 16. And wherever it says x, I write that expression that I've just found. So in other words, 3 times 2x, 12 plus 4y over 12, plus 2y equals 16. 5. Over 5, is it? Where did I get 12 from? No idea. So to solve this, I'm going to use some of the tricks I've used already for solving equations. First of all, if I've got a division in there, divide by 5. If I multiply every term by 5, I'll get rid of that divide by 5 underneath. So I'm going to multiply every term by 5. If I multiply this by 5, it gets rid of that divide by 5. But I've got to times this term and this term by 5. So I get 3, 12 plus 4y plus 10y equals 5 16s are 80. So I multiplied every term by 5 to get rid of that 5 in the first term. Now, expand out the brackets. 3 times 12 is 36. 3 times 4 is 4 3s are 12y plus 10y equals 80. Now we can collect like terms. 12y plus 10y equals 22y equals 80. Jack, at the back, happy so far? Good, I'm just checking. What would you do now? Right, good. So 22y equals 80 take away 36, 44. So y equals 2. And we've got the same answer that we had by the elimination method. More algebraic steps, and I wouldn't recommend you use this method in this case, but as I've said already, there are some times and some examples where you have to use this method. Once you've got one value of, like we did before, you would now substitute in that value of y into one of the original equations to get x. So then the method will be the same from then on. The first part is this departure, the new idea, rearranging one of the equations for one of the variables, x in this case, and then substituting that into the second equation. And it does require more confidence with the algebra. Yep.